Hi, boys and girls. All right, for Miss Godfrey, this is the last of 5 sets of videos for the day. So I'm so excited to be doing this last one for you. It's only number 2 on Monday of 2 weeks from now. Anyway, all right, so you just watched a video where Will, Nick, and I were collecting data from a walk where Nick did absolutely no walking whatsoever. He stayed on the 5-meter card, and I just tabbed did some splits on the timer to collect some seconds to graph, because I really want you to see on what it looks like when there's a graph where nobody's moving at all. Had we had EOGs, this would be like a 100% sure thing that would have been on your EOG. So, you're still in 5th grade, whether you have a test or not, you might as well learn all the 5th grade stuff. All right, without further ado, here's the data table we made while we were collecting the data. I have already taken the liberty of creating the coordinates from that data table. Please keep in mind that every graph has a title, so you know the main idea of the graph, that the y-axis should always be labeled, as should the x-axis always be labeled. When you're numbering your graph, be careful to number on the lines and not in between. It would be delightful if you could write in those boxes, because it's super duper fun and just write a number in, but that is not how it works. You have to write your numbers for your distance and for your time on the lines, because remember that your coordinates are where this line, the number 1 line here, and the number 1 line here meet, right at the spot that they intersect. All right, with all of that graphing information out there once again, so hopefully hearing it about 80 gazillion times, you always remember it, because you'll have to graph in higher math and science a lot, especially in algebra. There are equations that make different slopes, and so you just gotta roll with it, All right, so for my first point, it is 0 and 5 is the distance. At 0 seconds, Nick started off at the 5 card. All right, at 1 second, Nick stayed at the 5 card. At 3 seconds, Nick was still at the 5-meter card. In a shocking turn of events. At 7 seconds, what do you know? Nick was still at the 5-meter card. And then at 8 seconds, surprise, surprise, he was still at the 8-meter card. And then at 10 seconds, he was still at the 8-meter card. And then I stopped collecting data at 12 seconds. Now, as you can see, and as we talked about in a different video last week, a horizontal line is what shows up when you have absolutely no motion. Because Nick stayed at the 5-meter card, represented right here with 5 on the distance side of the graph. And I randomly collected samples of times, but Nick never, ever, ever, ever moved off the 5-meter card. And when you do that, you create a flat line on a distance time graph. It's called a horizontal line. Horizontal, and I know we talked about this last week, but you can't hear it enough to make your brain remember it. A horizontal line equals no motion. No motion at all. Motion has stopped. All right, a horizontal line, no motion. That's a key ding, ding, ding fact for 5th grade science. And now you know, if you didn't know before, but you probably did. All right, love you. Mean it.